So we had earlier, we had planned for one lecture of the CIoT, okay, cognitive Internet of Things. Then when I was trying to look back, we found that it is too much. So I took a step back and split that into two lectures. First one is artificial intelligence of things called AIoT. Okay, that will be this hour. The next hour will be talk about the cognitive Internet of Things. Okay. And this particular slides, lectures, has been based on actually those two references. Okay. Our agenda is we'll introduce what is the artificial intelligence for IoT, then the AIoT's progress and challenges. But that will give actually a good base when you jump into cognitive IoT. Okay. Now, artificial intelligence has been embedded in many of the devices, as you see here. They can pick just 3 examples, like a Roomba, that's an iRobot, and this vacuum cleaner maps your room layout and clean it depending on when you ask it to clean, and after being cleaned or when the power is exhausted, it goes back and to the dock and charge itself. It has some intelligence built into it, AI. The next thermostat, remotely, I can easily go and just change the room temperature, set various things from here for my house. Okay? Then Tesla is self-driving vehicles. That's a typo there. Okay, sorry for that. Okay, right, typo there. I'll fix all these things before I deliver to you. Okay, so this is called car as a thing. The automobile is a thing now, and particularly these Teslas, and there are many other players in auto industries today. They have autopilot systems which incorporates GPS, camera, sonars, and so many things. Okay. Now, here the interesting thing is Tesla gaining some experience wherever it may be in the world, but then entire Tesla fleet could be 500,000 or whatever it could be, different types. They operate as network. Okay? So, which means when one car learns something, they all learn it. Okay? So, it updates and everybody adopts that after being analyzed and seeing what is to be done, not to be done. Okay? Then the things enabled AI, that means things could be anything. Okay? Automobile or any of the gadgets you see, or you can even find it in the future. Okay? Things enabled AI in the IoT will result into the smart things. So, in a way, we are starting actually this cognitive business today after building a good background until now. Okay? So, the smart thing is nothing, but we know that they are enabled with AI capability. Okay? So, you have these things, they generate data, analysis happens, okay, then they move to building intelligence, and better things are produced. So, what is AI as a formal definition? AI refers to simulation of a human intelligence process. Okay? Simulation of human intelligence processes by computing entities. These processes include learning, reasoning, and self-correction. Learning is getting the data, finding the rules, capture that. Reasoning is able to discern or make a decision. And self-correction means if something they see it is not necessary or is overdoing, curve correction, they can fix it. The advantage and disadvantages are very simple. Typically, AI assists human to solve the complex problems. It's pretty convenient when man and the machine interacts, and that way you can possibly replace some of the human oriented tasks by machines which will be doing it on behalf of the human being, and most of those tasks are repetitive in nature and laborious in nature. And also, unlike a human being, a fast decision can be made, okay, when it's necessary to have human replaced. In another way, you can say, when emotion is involved, people need not be blamed for that. Give it to AI, so that let AI be blamed. Okay? There are many, but there are few at the forefront. Disadvantages are is expensive storage. Not a serious issue though at this point, but it will be if the proper thing is not taken care of. Then costly to implement everything, want new things, you want to remove the laborious task or even work to be done in the hazardous place, then it needs cost, so you have to pay for that. Now, other thing is less creative compared to human beings. That's true. Okay? They cannot be creative, at least at this point. When the cognitive aspect is improved, then things will change. Now, what is the difference between AI and IoT? Okay? Now, we'll look into this aspect as a system and objects, cloud computing, and data and behavior point of view. So, these are our parameters to compare AI and IoT. AI is all about system behavior, whereas IoT is an inbuilt entity inside the system. Okay? One is behavior, another one is object itself. Then from object point of view, it does not specifically need objects. It is system itself, it's software, algorithms. Whereas for IoT, is mostly concerned about objects that is provided with sensors to capture sensing data. Okay? And AI is strong connected to cloud, whereas cloud is used to manage data by IoT. Cloud is used to manage data coming out of IoT. Okay? Now, computing also is again depends actually. You need a lot of computing for AI, different levels. Okay? But IoT case, yes, it involves computation when you get computing activities to be done by it. Sometimes just sensors pass the data. Okay? So, depending on the IoT level or size of IoT, the capacity of IoT, then it is possible that computing is necessary there, or otherwise computing is going to the next level. But in general, you can say computing complements the IoTs. Data point of view, AI needs a lot of data and patterns. If they don't get data, this is the main food. If they don't get this data, they can't really survive. Okay? Whereas for IoT point of view, it's all about sensors. Okay? Sensor generates data used by AI. Okay? Behavior point of view, for AI is about instinctive response to the received data input. That means you have to behave depending on what kind of data you are getting in. Whereas IoT is already predefined what response will be used for what kind of data that it gets from sensors. So, the firmware typically have the code or the rules that are collected to clean it, send it, or do some minimum computation. So, it is kind of pre-programmed or predefined here. The three level of AI: narrow AI, when machines can perform a task better than us human beings. This is narrow. General AI, machine performs intellectual tasks as humans. So, at same level. When AI beats human beings, is active AI. Okay. Some examples you can see later. Now, let's define three things. We define machine learning, AI, we defined AI already, right? Now we define machine learning, then we define deep learning, see the relation between them. The machine learning is a method of data analysis that automates analytical model building. Essentially, machine learning is nothing but an algorithm or analysis technique which has some autonomy built into it. Rules is rule based all the time, uses algorithms, that is iteratively learning and from data. So, this is a key word, iteratively learning. Okay. Then machine learning allows computers to find hidden insight without being explicitly programmed where to look. So, that is the beauty. Okay. So, machine learning is power comes, it involves a lot of data, work on that iteratively, analyzing that using many algorithms, and there is no direct way you can say I can find this insight or that insight. The insight is coming out of algorithms and iteratively using them. Then though there is no program written, give me this, give me that, but automatically it comes out from the data that is being learned by the machine learning. So, we saw AI, now definition of machine learning we just saw, and when you compare them, it might give a better perspective. AI is a program that gives output to human, whereas machine learning is a concept behind the program. Okay, it's a concept behind program. Without that concept, the program is not going to be helpful. And machine learning is a part of AI though. Okay. Then AI takes decision. AI is actually the big umbrella. It has other things. Okay. So AI takes decision. Whereas machine learning learns new things and applies it. Okay. Machine learning learns new things and applies decisions. Okay. See how closely they are connected. AI aims to simulate human intelligence, whereas machine learning aims at learning as much as possible. So, machine learning is a good student, keep learning all the time. Okay. AI is the instructor. Okay. Ultimately, AI focus on intelligence, whereas machine learning focus on learning and knowledge enhancement. Okay. Keep learning. Okay. AI's emphasis is on getting tasks done, whereas machine learning emphasis to learn and give answer as accurately as possible. Okay. Now you can see here, AI, the big umbrella inside, you have machine learning cell, is actually onion, okay, and very deep inside, just deep learning, okay. So what is deep learning? Time has come to see that. What deep learning? In few slides, you can clearly see all those differences and the relation between them. deep learning is a branch of machine learning. Okay, machine learning coming, helping AI, deep learning is a branch of that. So basically, these are both deep learning, machine learning. They are all learning business, in learning business. Okay, one may be an honor student, one is possibly the first class. Okay. Now, it's a branch of machine learning based on a set of algorithms that attempts to model high-level abstractions in data by using multiple processing layers with a complex structure. What it means is in deep learning, it starts getting the data. It depends on more data than just machine learning. Okay? So it is always starving for data. As much as we give, still is not enough. It's like that, ever hungry. And when you look at more data, as much data as possible, is trying to find out the abstract, the behavior that is going through all this data. So it sees a pattern. It sees a more insight which is more profound in nature. Okay? So deep learning deals with a lot of data, find the critical model or the rule being built into all the data set, brings it out, which is not possible by just simple algorithm. That's why they're using all those features and artificial neural network, okay, different, all the kind of network that are being there. Each network has been, artificial neural network I'm talking about, neural net in general. A different aspect of neural network is used for different purposes, different kind of applications, okay? And they usually have many layers because each time you go through a layer, you extract more features, okay, multiple layers. Okay? Now, handcrafted features and a shallow model in machine learning are unsuitable. That means it is possible that sometimes machine learning will fail. Then deep learning will start to take over, particularly multimedia applications and high dimensional unstructured data machine learning cannot deal with, that deep learning can help. Further, deep learning is successful in applications like speech recognition, face recognition, image classification, object detection, semantic segmentation, and natural language processing, so many things. Okay? So these are some of the example I was talking about to extract feature, then train classifier, machine learning. This is you are applying actually neural network, deep neural network, DNN, and do the same thing also. So as we always discuss a platform, okay? We have platform for AI capability. And afternoon we'll see, not afternoon, after next hour we'll see there are also same vendors provide platform for cognitive activities. Okay? The machine learning versus traditional programming. If computing is the business that to deal with, in traditional programming, you provide data and program. Basically, you write program, your code, and provide the data input, then data is being used by the program, get the result. Whereas in machine learning, you get data and the result, what you expect, what you want, then program can form. So you learn giving what, suppose I want to see a deer. I have a lot of data, I don't know what they are. Then what kind of program will help me to give deer? It's kind of a backward. Two types of AI, okay? Traditional or symbolic AI, okay? The first one is actually machine learning kind of things, okay? The traditional symbolic AI is based on representation like rules and knowledge, typical machine learning. Whereas statistical AI driven by data, primarily benefiting from deep learning and neural networks. So this is your deep learning, which is statistical data, or even just data structure, unstructured, any kind of data. Whereas this is algorithms, numerical methods, mathematically, that is essential machine learning, is this category. So this gives actually comparison knowledge based or knowledge enabled AI versus data driven, which is deep learning. The basis, you need to have prior knowledge and rules. Here you don't need that, all you need data. Advantage, strong logic and perception cognition is there, whereas here it is much more objective. Okay? Little human interference is necessary and crucial reasoning mechanism. We'll talk more on those things going forward. So disadvantage is actually, you can see robustness is low, okay? And when complexity is increasing, difficult to describe, formulate for the large problems, but for small problems it's okay. And typically the influence of knowledge inventor is significant here. Now, when you want to refine the rules, given initial rules, it takes tons of iterations, which is much easier in case of deep learning. But in any case, the disadvantage of deep learning or data-driven AI approach is data incompleteness. That means you may think, okay, I have got 20 GB or 2 terabyte of data, but that could be incomplete. Okay? And sometimes set of data could be different from other set of data, and deep learning gets very hard to find commonness. And we call all those things as data inaccuracy. And definitely it's more costly than anything. Okay? Now, back to our goal is all that given definitions. We got definition of AI, machine learning, deep learning, the relationship between them. After that, our goal is to get the AI into IoT. Okay? How do we connect together? Now, yesterday we talked about 3-layer, 5-layer, okay, and up to 11 layers. Okay? Now, to make life a little easier, we start with a 3-layer or 3-tier IoT architecture: perception layer, transport layer, application service layer. Okay? You know by now that this has all the devices, GPS and mobile, all those things there, which is sensor provider access platform for the sensors. Then you have both cellular and non-cellular network, different protocol we talked yesterday, and they facilitate the communication among them up to the next layer. And application service layer is typically connected to cloud and the application that necessary. Other verticals are always there. We don't talk about this now. You kind of imagine that they're all there. So what we are trying to do next is we can see how you can push AI into this layer, how to push AI next layer, and so on. Okay? Now, how do you converge AI in the sensing layer, the bottom layer? Okay? Now, one line answer is by selective sensing. Okay? There are two kind of AI we discussed before. One is a machine learning type, or let's call that knowledge enabled AI. Sometimes it's overlapping, so better call them this way. Instead of calling machine learning and deep learning, the majority way there, that's the way, but let's call knowledge enabled AI and data driven AI. We compared them already, right? Now, this is a real tool. This is the commercial tool. I believe it's open source, I guess. Then this one is in neural gas network deep learning. These are techniques, algorithms, techniques, tools, algorithms based on these ideas. So the selective sensing is the fact that you have got so many sensors, so many data, so many tasks to be done. Now, it's impossible to hold everything together. Okay? So, you have to be very selective in choosing those sensors from the environment, and you can only sometimes open this, open that for communication. Details are given here that because of the large volume of data, types of sensors, types of data, and multiple dimensions of sensing. So, it comes to a stage there could be uncertainty and high complexity in dealing with them together. So, there is no certain discipline yet when you try to grab a particular level of IoT and deal with it, and we have to enforce some amount of discipline there. Okay? Now, when you try to put AI into it, essentially the traditional algorithms that cannot be successfully acquire the data and process them, where when you use AI based selective sensing case, it knows the capacity of the computing there. So, it can only grab that amount of data selectively looking at the priority and process it. Then select another part, kind of batch mode type. It's not exact batch mode type. Select a bunch of signals from now, data now, from 5 to 6 sensors, then go to next batch, or they can see which is more important. So scheduling, we'll learn scheduling in the next slide, I believe. Then you can see that by building AI into sensing layer, you are selectively choosing sensors and passing the data instead of using just traditional algorithms. And the convergence of AI achieves technical breakthrough in dealing with explosive data. Okay, here is the thing. You might have heard, if you are working in this machine learning area, convergence is a very important thing. Okay? You say when to stop because you are collecting data, you are learning. When you want to stop, there is no end of that. When convergence is made. What is the convergence? Agreement. When all of us agree to a point, oh, this is the cow, that's convergence point. So if their camera, they are picking up for images, as image sensors, data, and they keep finding out what is this, is it lion or cow? Now, after doing iterative operations, applying algorithms, then it confirms after so many iterations, 5 million iterations, this is coming out as cow. So somebody has decided that, okay, this has to be stopped now. So convergence is a big thing that is necessary to achieve, and you cannot achieve opening horde of sensors to jump into the game. So by selective sensing, you can control the data particularly needed. And sometimes, if you don't go for selective sensing, you might be getting data from different kinds of things. Then it will be confusion too. We'll also, tomorrow we'll discuss, tomorrow, day after tomorrow, maybe tomorrow, we'll be discussing on multimodal sensing, multimodal IoTs. There you typically get data from multiple sensors, but they have to be cohesive and other relation constraints are there. Now, same time, since there are limited sensing resources, so your selective sensing has been proposed when you want to deal with the sensor layer and to improve accuracy too. So basically same thing, we're talking same thing. Now they give me an example here. You want to identify a particular image that from the satellite, you get the top view, apply deep learning, then you found some data, oh, this is a vehicle, and you stop when the accuracy built to 96%. Now one thing, the time taken to go to 96, then time taken 96 to 97 is a huge difference. It may sometimes take more time to go to 96 to 97. So you have to call it off. Okay? Then other example from machine learning point of view is a context-aware sensing platform, CMOS DEN, that is, it was in the last slide, okay? It is proposed, and that depends on selective mechanism. Okay. Second is, let's take next layer, how AI is helping in network layer, or how you can build AI and the purpose of building intelligence in network layer, how it helps there. Now, short answer is the network layer, what it does. In network layer, it routes, communicates both directions. Okay? So with AI, you get efficient communication to happen. Okay. The routing path selection is, you need some intelligence, that is provided. These are the algorithms used or picked up by the AI approach to give a near perfect path for communication. Other big thing, network scheduling. Okay? Some work has been done in this area. In fact, all these things actually part of the research, ongoing research you can also do. If you're interested in this area, you can grab on this research in this area. So network scheduling is a real big thing, because if scheduling is not done properly, you may hang, or you may get into collisions, you may come across other issues, communication will be more expensive. So they use reinforcement learning, neural networks, machine learning to get efficient scheduling. Then data fusion and compression. Data fusion means you get data from multiple sources, you want to put them together to process. Sometimes you have a lot of data, then you have to compress it to send it to help reducing bandwidth. Then on what principle do compression? How much compression to be done? Okay? That's essentially possible by training and learning process. And they use genetic machine learning, deep learning to achieve that. Okay? So the last one is the sensor layer. Then for router, all the way to server communication, we are looking into these things. Then quality of service. I think some of you are working in the quality of service research, right? You are working, yeah, quality of service. So using neural network and fuzzy logic, some work has been done, but one can apply that into an IoT scenario. Easy paper, okay? Yeah, this is actually same discussion, I will skip it. Then converging AI in the application layer, okay? The top layer. Now, if you remember from last discussion yesterday, we have application layer with various aspects. There's one application could be on smart cities, this is smart medicine, and intelligent or smart transportation, and so on. Agriculture, and there are many, many possible applications are there. Okay? Now, from application point of view, layer point of view, what is important? Important is the service. Okay? Regular service and quality of service. Don't worry about quality of service there now, it's a service. How much service to be done? And we have to make a balance, because in application layer, there are a lot of demands. It talks to cloud. At the same time, it goes back to help actuation to happen. It's both way. So when you apply AI in application layer, they try to be helpful in adaptive services. Adaptive means, which suppose you are doing some work, say, think about smart cities. Anything you take, let's smart cities. In smart cities, you you have so many activities going on. Utilities, cleanness, camera looking at the lights, so many things are there. Tomorrow, there are more services being added. Some services are replaced by new techniques, new technology. Then is your application layer ready for that? In ordinary application layer, they are not ready. But if it's a AI empowered, then they will be able to handle that by adapting new services, adding even new domain, new applications. You can add more services or enhancement of certain service in a particular category. Okay. Then one more thing is also important in application layer. That's called semantic. You'll be hearing semantic more often, particularly if you would like to know more about these cognitive things. Semantic is a very common word you'll be seeing. So what is semantic? Meaning, correct. Meaning, okay. Now, if I am coming from one state to another state, a particular object, particular item has different meanings. In other words, is more applicable that, okay, suppose this is a pen, okay. Pen is easy thing, okay, everybody says pen. I have an example. I wanted that seed, ajwani, right? I want ajwani. Then I don't know what they call it here, okay. So there is no common ground to call spade as a spade. So the semantic is something, ontology, all those helps to explain that, okay, if I say, I'm with my background, if I say this, I'm at a place Y, then the meaning is this, okay. Suppose a query comes from Telangana, a query comes from South Africa, okay, a query comes from Brazil. They are all going to cloud. So unless we have a semantic based analysis, semantic based communication, semantic network built there, it's difficult. Okay. Anyway, other thing is the recommendation system. There's another term you'll be hearing. Okay. We did bunch of work actually in recommended system. Our 3 students did PhD in that several years back. And some of them use semantic. I think we built fast semantic network. Okay. And we can talk later based on the semantic network. It's not the topic here, but that is something I saw industries already using last couple of years. The recommendation system and algorithms are used for discovering relevant products and services by users. Can you give an example? What it means by that? You know, where do we use recommending systems? Netflix. You saw some movie, you rate it. I want to see a movie, but I don't know where to start. Then I get a recommendation by others. Same thing in Amazon, also doing same thing. You want to buy something, you look at how many people liking it, all that, okay? So how it is relevant here? Well, it's application layer, does services. That's what Netflix and Amazon do, okay? So recommending systems or recommendation systems, people tell recommending system, recommended system, recommended system, same thing. The recommendation system and algorithms are used for discovering relevant products and services by the users. Got it? Semantic web technology are employed for semantic annotation. The difficulties are talking about. Conversion particular point. We should not think this is apple, we should know this is orange, that don't work. So the technology are employed for semantic annotation and reasoning on data to build interoperable application. See, why interoperability word is used here? The interoperable word is used here because it's working. If you if you fail providing the meaning, a common answer through meaning, it should not be you and me tell apple as orange and grape. Okay, so you should say apple as apple. Okay, so the interoperable provision is essentially saying, okay, we all agree that no confusion. If I pick a word at any part of the world, its actual meaning is understandable by the user. Maybe an image comes, it look at the image, and to my query, it answers in my language, to you in your language. That's possible. Okay? In general, both knowledge-enabled and data-driven AI, basically both machine learning and deep learning, have been widely used in information mining and recommender systems and have shown extremely high performance results that is appropriate for the application layer. Okay? So what is the state of art in this area? Well, in AIoT has got three-layer or three-tier computing architecture: edge computing, fog computing, and cloud computing. Okay? You might be already seeing these things in any wireless network class or just network class. Now, all this essentially has been augmented with IoT activities. If time permits, we'll see. I have a sort of slide on fog computing for IoT. We'll see if it's possible or not. So this looks like this structure, computer architecture for IoT. This is a architecture for IoT. Okay, it's the edge computing layer. You have all those gadgets, okay, objects, sensors. With sensors, they are there, and you have a fog computing layer. Then a cloud. I think all of you are familiar with this structure. This is nothing new I'm showing here. What is new is how AI is being held there. Okay. Now, for sake of IoT getting a force into the business, they mean to, the cloud is a elastic computing resources. Why elastic? Depending on your need, appetite, you can get it. Okay. That leverage all data from registered devices in IoT applications and only train those things either deep models, okay, so that you can have the proper abstraction of your data given to you. Now, what happens for computing? It does more or less same work, but it is closer to your sensor or objects. So that way, it brings storage computation. That's what exactly it does too, close to the ground. And bringing closer to ground, it offers low latency because you don't have to go all the way to cloud, okay, and sometimes keep weight there, queue there, and there are more in fog computing. You have got more number of fog nodes connected to the ground. Ground means the sensor layer, okay, or object layer. That way you get low latency and also improved security. You don't get 100% security secure, but at least get better security compared to if just cloud, no fog. No fog means this goes directly there. This means sensor goes directly there. Now, in this architecture, IoT architecture, you have cloud, fog, and edge. And edge computing is the computing power coming close to on the same level on ground. Okay, we call that edge devices nothing but your actual device sensors and objects, that is has sensing capability, computing capability. So obviously, as we going down, you have latency, further reduced latency, and network bandwidth is least used, and your privacy also very improved. This is the perceiving. This is the perceiving means how to feel from sensing layers. Okay. This is the fundamental of our AIoT system. What notice here with respect to IoT, okay, I can read from here. This is difficult to read from that side, okay? Or maybe I come here, okay? Now, this is, let's go from left to right, okay? This is generic sense understanding. Okay, you have image classification, object detection and tracking, semantic segmentation, and text spotting. They are very powerful, very standard services is being used. Do you know what text spotting means? You're giving a picture advertisement, you have to capture the text. Okay. Then human-centric perceiving means you have got biometric recognition, person identification, human pose estimation, yoga and exercises, or even senior facilities, human action recognition. So these are the action-related dynamic scenario where we call human-centric perceptions. Okay? Now, you have natural language processing, speech recognition, multimedia analysis. Okay? Now, what it says, this is what you see here are some of the tasks that intelligence are building off for IoT. First of all, these tasks are IoT related, because when you do all these things, you have a camera there. It takes the still picture or videos. Same thing, you have mostly static pictures. I mean camera, the pictures, images, analyze those things. Speech recognition, it's kind of dynamically talking, it's moving things. Natural language processing in the next level, built with AI, language translation, many things like that. Okay? And depth estimation is very useful in applications for when you try to move, and you means not necessarily you, suppose you have a automobile, a car is moving, then how does know it has camera, no, nobody is driving it, how it will know that it is a 1 meter deep is there, or it's kind of a plain land. So that's coming along with the other aspect of automobile, self-driven one. Okay? So in a way, all that you see here and much more like them, they are actually called perception layer activities. And that is fundamental for you to start. You build, just like discussed that, okay, in sensing layer, how you can build your AI into that, selective sensing and all that. So those things you can do here actually. Now learning in AIoT. So how do you learn in AIoT? Now let's look at the picture, okay? You find several learning techniques. Supervised learning, unsupervised learning, then you have got self-supervised learning, then few shot learning, zero shot learning, we'll talk on the Friday those things, then transfer learning coming between them, and when it is combined to semi-supervised learning, okay, then there is one reinforcement learning, then this is a federated learning that is distributed, more suitable for your IoTs. We worked quite a bit on this area too. The new thing is coming last year or so, again, we possibly second or third group in US or maybe world that we're looking into this, called incremental learning. Incremental learning means you have either any of these techniques, all of them maybe, they are learning. Given some data, they're learning. You want to learn new things, what you do? You throw the data, you get new data. That's very expensive. So what we came up with the idea, okay, we'll not change anything, we want to do incremental learning. That way you quickly don't throw in data, as you go, you include new data. But selecting the data for new data is challenge. Okay? So you have to optimize data. We call that data kernel. So we build kernel and push that into the ongoing learning any type. We did not try all of them, we tried actually main ones. We found it's doing great. Okay? So incremental learning is going to complement that. It was not there actually in the original diagram I just added last night. Okay? But whole idea is AIoT can learn any one of those things, the real world scenarios. First of all, why? Whether incremental or all this learning coming from? It's because you or the system does not stay still. Okay? They continue to move with more data, more complex tasks, more complex systems, more dynamic in nature. So any idea we push for fixed model, they cannot stay the same way as data in ecosystem, they vary. Okay? Now we need to allow those IoTs with an ability that you not only learned, but you will keep learning. They call lifetime learning, okay? And evolve with response for the changes in the surroundings or ecosystem. So these are the few research topics in machine learning for IoTs. A lot of work has been done in this area already. Unsupervised, semi-supervised learning. They use DNN, autoencoders, then GAN models. Yeah, if you speak on each slide, bullet will take a lot of time. Just kind of give a note to you so that you can read yourself and build the ideas over there. If there's something very different, I can certainly note it down. So GAN models have been proposed that can generate high resolution and visually realistic images from random vectors. Paper and big GAN. Then other hot research area is on self-supervised learning, which essentially learns in a way mostly applied to visual or the image tasks, imaging tasks. Okay? And another tool actually is SimClar. Then semi-supervised learning is the amount of on-label data, because data, the bad news for this any of this IoT, AI business or learning business is data. Sometimes you wasting your time on bad data, unstructured data. So a lot of work need to be done in that area, that automatically how data can be cleaned, okay? How you can label those data, because when you have trillions of data available to you, who is going to label that? Okay? Even the simple, the doctors, you visit doctor, whatever he talks to you is kind of recorded there. There's nobody to label that. So they send actually the transcriptor sitting in village areas, who knows English, they have been trained what to do. Okay? But is it possible? Even 8 billion people are there, not possible, the kind of data coming out. So that's a big headache. So how to automate those things? Okay? So anyway, so these two areas are still struggling, and more work necessary here. Reasoning. What is reasoning? Is another factor. In our real world, there have been much knowledge carried by web information. Okay? Medical records, financial transactions, and there are many such scenarios, and which can be used to reason the answer to a question or infer patient code. Because doctors have the medical records, and based on their expertise, they reason the patient is suffering from this and that, how to help. Similarly, looking at the financial transactions, bank transactions over a period of time, people say, economists know that whether the economy is going to slow in the next 6 months or 1 year. Okay? Now, these are, we call that the region. The region comes from experience. because what is expert? Expert means expertise in having experiences. Okay? So, you or anybody can reason only when you see the trend, data trend, and based on your experience you can say that. When you try to sneeze, your mom says you are suffering flu, okay, because of experience, the sneezing symptoms, simple thing. Okay? So, the bigger things are there. Obviously, you and me cannot say, looking at financial bank transaction for last 3 months, 6 months, we cannot say economy is slowing down or looking promising. Okay? So, we expect the smart devices should be able to reason, and all this we are talking about is because of reasoning ability. So, can you empower these IoTs to reason when they have data? Can they reason? If they reason, then they can take decisions, because they are the entities who are generating data, and data gives to knowledge. Then we apply reasoning to knowledge, get decision. Okay? So, knowledge graph is a presentation of reasoning. Basically, knowledge graph is used for reasoning. Okay? Now, KG means knowledge graph, is a structure, is a way you can represent knowledge, just like tree graph actually. Tree and graph are different actually. Okay? The nodes represent entities, and the edges represent relationship between the entities. Okay? Now, if you know you have knowledge, you can create algorithm to reason. Okay? Then knowledge reasoning referring to inferring means deciding new knowledge based on the existing knowledge. Just I told, mom can know what happens to a child. Even sometime you yourself, based on your experience, you feel. If you have enough experience as you grow, you can feel the same way. Okay? Now, so the summary of this slide is actually saying that, okay, there is a way to formally do this thing. You can have knowledge graph and apply techniques to infer what is going on over there. Classical knowledge reasoning methods based on rules. So, basically same thing. You have the knowledge, then put rules to arrive something. And it's easy to say there are other things actually. Once you go deep dive into it, you find, okay, the rule have to be a certain control over there. Okay? Otherwise, kind of sometime you ask, ChatGPT is supposed to be the best one, then you ask a question, and sometimes 1 or 2% time maybe it gives some stupid answers. Okay? So, because the stupid rules are applied, so you have to be very careful and do that. And also there are other issues in terms of ontology and languages. Okay? And they use, essentially they use rules, different kind of rules, logic and predicate logic and probability rules, and also ontology language, semantic things, path rules, applied to knowledge graph and derive the infer the this. We are close now? Okay. How many are left? Okay. We should have done in 2-3 minutes, okay? Okay. Then causal reasoning, the process of identifying causality, is basically cause and effect things. Then causal reasoning is useful in many IoT applications such as online recommendations, in smart e-learning, fault analysis in smart grids. If this happened, if this is a condition, that has happened. Cause and effect kind of things. Is another way you can see, get the infer from the knowledge. One can apply DNN to arrive that. Now, we have at least some understanding now what is AIoT, how it is applied to various layers. Then we also learn that, okay, given those data, we can have a knowledge, we can build knowledge graph, then we can apply rules to get a decision on what is happening from or based on knowledge and data. Okay. Now, the challenges are, there's a few half a dozen challenges I believe. There are multimodal heterogeneous data processing if you have got multiple mode. We are taking up actually tomorrow this one. Then deep learning on edge devices because limited resources there. So processing streaming data in real time is a challenge, how to do that. Deep learning can do that, but they need a bigger processor. There are ways, approximate computing and things like that can help, but this is a challenge now. Then computational scheduling in the AIoT architecture, just like network scheduling, networking, all those things. That's still an incomplete problem. Big and small data for deep learning in AIoT. So same thing is similar to this actually. Data monopoly is another way. Now there are a lot of new startups, new business coming up. They create data, and they are proprietary, they don't share data with anybody. That means they build data, they don't share, so they have all the data. Other people cannot do that, cannot match with them. So there's no rule, no policy say, hey, you give the data to others. So that's a serious concern to the community. As usual, this you will find every time something comes up, data security and privacy. Growing energy consumption, imagine 7% of global usage of electricity is used by data centers. So coming years we will be using more data centers, this will go up. Okay. At the same time, when you have challenge, you have also opportunities. Built-in neural processing capacity for edge devices. We can produce more computing power, more algorithms at the edge. Then event-based sensors and neuromorphic processor. Some work already started in this area. Sensors have the neuromorphic processor there. Another item actually I didn't mention is using silicon photonic architectures. They are very fast. Okay. Deep learning, we have validated, we have published a number of papers actually taking deep learning in silicon photonic architectures. And deep learning from virtual to real. You remember that we were discussing the application yesterday with a virtual grid control once. So that we're saying, okay, instead of virtual, you see the virtual, that's fine. But what happens in reality? The virtual is virtual, it's not the replica for, it's close but not the same. So if you study something, simulation, everything looks great. Think about we have a simulator, for example, that make the automotive decision on car, that moving car, driving, self-driving car. That's in the lab, virtualization. Can I take that and put that in a real car without thinking anything? So those kind of things are virtual to real is a challenge. Data and knowledge integration, that whatever we talked for several minutes sometime back, and that is also a growing concern. Okay? Privacy to preserve in deep learning. So the conclusion is, we discussed few architectures, technology, and relation between machine learning, deep learning, all those things. And there are so many learning techniques available: unsupervised, supervised, semi-supervised, reinforcement, and incremental learning. They're all, so it's not possible that anybody can give you a lot of things in 1 hour, but at least now your antenna is up. You know that these are things happening, the relation between them. You have some clarity at this point, so that next time you read a paper for you, then you can easily connect. It's better than saying nothing and wondering things. Okay? So in the future, it is possible that we can empower the AI technology and with all those knowledge and inference capabilities. Though we have something there, but we have to take it to the IoT level. And it has to be resolved at a fast rate. with high speed, and we can call that the green technology or whatever. Okay, and to keep the IoT's applications safe and help the world to move further. That's all the question. Please, questions, please. Yeah. Sensing slide. In the beginning? This one? Yeah, yeah. This, this one, right? Okay. This. Ah, okay. You have the processors there, right? Yeah. Yeah. So this selective sensing will be is an algorithm typically, okay, a software technique that will be added to the operating systems. Okay. The privacy and security is always there. If you all the computation being done at the edge level, you don't send it to fog or cloud, so you get that. So many real-time applications you can solve it there itself. It's possible. And sometimes it's not that you always need real time. You have variety of tasks to be taken care of. Those who are low hanging, those can need definitely for real time. You process at the edge, and certain things computation can go and come back from either from fog or from the cloud. It can wait for slow responses. Let it go. So selectively you can choose, not this selectivity. So basically the idea is, okay, at the edge level you can keep what you can do at edge level depending on the computing power. The rest of them can go up, because anytime you send up, it consumes bandwidth, it consumes energy and increasing latency. Or all applications, all tasks cannot afford all those things. So whichever can afford, it can go. So you make a balance between how much will be done here. If you have got more scope to do things at edge, do it. Right. Correct. Correct. Yeah. Yes, broadcasting is easy. So basically for broadcasting you have to use the network layer. Okay, network layer, edge computing also has network layer. So that will be broadcast. Yeah. Yeah, so physically it looks like that to present things, but they're all together, right? But you say to present it or to show something, okay, we have an ecosystem or an environment. What is the environment? Without device is not environment. Device, something sensor, but the sensor want to work with our devices. So device sensor is environment. Then you have to have something sitting on there doing selective sensing. So they're all one, but to discuss, to explain it, you're showing them different. Then you can connect them. Okay.
Is there any adaptation? Suppose I change any sensor.
Yeah.
According to that sensor layer, can you do any modification?
Yeah, possible.
May change any environment and according
Yeah.
to that
Same situation. So the resource is something, you see something in one area helping and you want to use in another area, go for that. Yeah, possible. Not available, you have to build it. Nothing is available, you have to build it. Things are available, people are done it, selling you, open source, you get it. But don't expect everything is there. If something there, good luck. If not, we can always add it. Yeah, yeah, that's the way it is. You can change all the three things. Okay, you can configure network. Okay, you configure chain devices. You can look at IoT. It all depends on how much power is available to play with, how much computing power is available to play with, and how much task, everything has limit. We are living in a limited world. So every time it is always a limit.
Before going add-on changes, we have to check limit is
Yeah, right, possible. Or you can add always. You can say, can I add this thing? If you add this thing, does it add to power requirement? Does it add to latency requirement? Does it meet latency? It's real time in case that case.
we can remove some sections also.
Yeah, it can. If you not use something, not use more time, just throw it. So that's why everything is taken care of at the simulation level. Once satisfied, you go to the implementation level. Now, at the sensing layer, you have many devices, and you have got many sensors. They all coming up with data, and this data has to be either processed there or to go up. And the trend is the amount of data being generated today is just more than enough that any amount of bandwidth you allocate, then it won't go all the way. At the same time, all those basic tasks, they need not be done at the same time. And some tasks can wait to be handled data processing. Some data from some objects has to be taken care of right away. So we have a very complex scenario between device, data, demand, and in terms of bandwidth, latency, power, all those things. So there should be some agent, some AI agent has to sit there to look everything and process it. That is selective business. It select certain devices, sensors, and data to process now, then other set process then, real-time things taken priority. So that's essentially saying that.
So are some modern IoT devices they are already doing that? Like some
It's just going on. This is actually not very difficult even for you to do that yourself. You buy a Raspberry, couple of Arduinos.
Basic models are available, sir.
Yeah, that's available.
Actually, we have seen AI-based router is
Right.
there. How many phones are connected and how many networks are connected, you can see that.
This is only one. This is only one entity, one device. So if you think about it, you have got 20, 30 devices together, and your communication is not necessarily infinite wide, right? You can create that.
Can you correct me if I am right or wrong? Like I have 300 room classrooms over here, and I want only a particular one.
Yeah.
That one is the example.
Yes, that's possible. Yes.
That to
Suppose you have so many classes are there, but some classes are empty, nothing is happening. So there's no point in picking everything. You select will go for that. Yeah.
selectively
Select, yeah, right. Yes, there are other algorithms like selective based on demand, selective based on priority, selective based on real timeness, many things. So you choose algorithm, then you go for that. There's nothing hard and fast rule do this way. There's really something to work with reasonable achievement. As long as you don't violate the other rule, deprived validation. Fog computing is fog is between the edge and the cloud. Okay, so when we deal with fog computing, we try to look at how much computation can be done there, because for fog also the communication from the edge to fog is a wireless sensor. You might have some wire connections at the edge level, but not from edge to fog. So again, you have wireless communication there, but imagine the fog. Why they call fog? First of all, they call fog because cloud. Everybody see cloud up, but in the winter season and some other rainy season, you find its clouds are on the bottom. We call that a fog. So it's like cloud. So whatever doing in the cloud, you are doing next to you. That's the only difference, close to you. So if you get that clarity, then you know the answer now.
yeah. When we are doing edge computing means we are doing
at the ground, on the ground.
And all these nodes are connected to some gateway or something else.
Right.
And then
Sometime fog could you gateway also. Fog could you gateway. Yeah. Cloud. And many times you don't have to go to cloud, you are done if there is a computing power available, you do in the fog and do away with the things, tasks. Okay, thank you very much. Yeah, we'll take some break, 10 minutes break. You can start, yeah, 11 o'clock. That's okay. Yeah, we can take